Okay, in this lesson, we take a brief look at color, conversion, math, and shading state nodes. Let's open up this shader network that is assigned to our geometries. The AOV nodes will be covered in the rendering section of the course. Let's take a look at the color nodes. Color convert allows you to convert colors from one color space to another, from RGB to HSV and vice versa. Then we have the color correct node that allows you to adjust the gamma, hue, saturation, contrast, and exposure of an image. We've been using this node throughout the course. Let's quickly load this wood parquet texture and set it as the input for the color correct node. Let me also change the material preview to Arnold plane and open up a bigger preview. So we can invert the image values. Let's set the saturation to 0 to get a black and white image. Now we can invert the grayscale values. We have a gamma value, a hue shift, a saturation adjustment, contrast and exposure adjustments. You can obviously multiply or add certain values. First, let me reset all the values to their default states. For example, I can multiply the texture values with a red color, or let's add an image node and load this BW27 grunge map and use it as the multiply input. There you have it. You can add values, or let's say we can use the same grunge map here as well. I'm going to disconnect the grunge map for now. And set the gamma 2.8 and hue shift 2.7. And this mask value allows you to dial in the overall effect of the color correction, or you can use a grayscale texture to mask where the color correction happens on the input. If you connect the same grunge map to the mask input, you notice the color correction only applies where the mask input is white. We discussed color jitter in its own lesson previously. We have this shuffle node that combines RGB and alpha inputs to output an RGBA by default. You can shuffle the channels to choose which of the RGB or A input channels go to which RGB alpha output channels. And you have also parameters to negate or ignore certain channels. Let me change the preview to a simple Arnold sphere for now. Before going any further, let's talk about this value node within the math nodes. Let me add one. The value or constant shader outputs a user-defined constant value based on the selected data type. And this can be very useful. Let's say we have a standard surface shader like a plastic shader that the base color and the SSS color needs to be the same color, and we want to control that color from one place. We can connect a value node to both the base color and the SSS color, change the data type to color in the value node, and define the color down here. And now we can control the color of both of them with one parameter. Value node can output other data types like integer, float, vector, and string. And if you have no idea what these data types are, this is a good introduction. An integer is basically a whole number without decimals. For example, the number of lights in the scene is an integer value. You cannot have 3.5 lights. You have 1, 2, 3, 4, 10, 100 or more lights. But in whole numbers, you cannot have half lights. Float allows for decimals like 1.5 or 8.6 or 10,000.5. Specular roughness amount is a float value because it can be in decimals like 0.35. A vector is basically 3 floats. For example, the position of an object in the scene is a vector because it has 3 float values represented in X, Y, and Z positions. And string allows for text instead of numbers. When we were discussing the ambient occlusion node and used that trace set function to exclude certain parts of the car from the effect, we use this string data type. You can check that lesson out again. Conversion nodes allow for conversions between data types. Most of these conversions happen automatically, so you don't need to worry about them, but it's a good idea to try and learn a bit about data types, including integer, float, vector, matrices, and here we have RGB and RGBA as well. Let me show you a quick example. I'm going to add an image node and load this render from the color jitter lesson. I'm going to make sure we have an Arnold plane preview opened. What I want to do is to separate the RG and B channels of the texture first. So let's add an RGB to float node because RGB basically 3 values. So let's add an RGB to float node after the image node and change the mode to the R channel. And now we have extracted the R channel from the texture. Let's Control-Alt drag the RGB to float node. And by adding the alt, the connection remains. I'm going to change the mode to G. And now we have separated the green channel or extracted the green channel. Control-Alt drag again and separate the blue channel. Now we have access to R, G, and B channels of the texture individually, and we can reconstruct our texture using these 3 channels again. For that, we need a float to RGB node, and here we have, if you add 1, you can see we have 3 inputs for R, G, and B channels. So set this float to RGB node as the beauty shader and connect the separated R, G, and B channels to the respective inputs in the RGB to float node. And that's our texture again, but now we have individual control over the channels. For example, I can add a color correct node after the red channel and only adjust that channel. The shading state nodes allow access to ray and geometric properties such as the surface normal, the UV surface parameters, ray depth, etc. Let's run the IPR for now. If you add a state float, state integer, and state vector, each one will give you different data outputs. Obviously, the data outputs from the state float will be from the float type, from the state integer will be integer, and from the state vector will be vector. Let's set the state vector node as the beauty port and change the variance to PO or shading point in object space. Our geometries are just black, and that is because the state vector node outputs a vector while the beauty port needs an RGB input. So let's add a vector to RGB conversion node after the state vector node. And now we can see the shading point information for our object in the render. Most of the time you don't need to do that as Arnold does it automatically. For now, let's stop the IPR and open up a material preview window in the Arnold plane mode. Finally, let's take a look at some of the more important math nodes. You can use the math nodes to perform mathematical operations. We have used complement a fair bit throughout the course, which inverts the input. Multiply allows you to multiply input 1 by input 2. Let me just control drag this wood texture and the grunge map. You can use the wood texture as the first input and the grunge map as the second input. And we should get what we hope for. We have this random shader that outputs a random color from various types of inputs. If we run the IPR again and add a utility shader and change its color mode to object and shade mode to flat, and set it as the beauty shader. Now each object gets a random color, but we cannot control any aspect of that randomization. But if we connect the utility node to the color input of the random node and change the input type to color, Now we can change the seed value and get different colors or turn them into grayscale values. We have this very important range, which remaps the input from the input min and input max range to the output min and output max range. Let me stop the IPR and open up a material preview window and change the preview to Arnold plane again. Set the range node as the beauty shader and connect the grunge map as the range input. Our range node is widely used to remap the values from the incoming map to a new range. I can, for example, increase the output min to 0.2 and decrease the output max to 0.5. Now we get a map that has a smaller range and therefore less contrast. I can invert the map by changing the output min to 1 and output max to 0. Okay, so that was a brief introduction to color, conversion, math, and shading state nodes. See you in the next video.